Back in 2017, with 4 million subscribers, Linus Tech Tips made a video where he built the world's highest airflow PC. Today, with 180,000 subscribers, I am going to beat that record with nothing other than household items. Back in 2017, I was just in the first year of this channel. I was starting out and I knew nothing. The one thing I did watch though was Linus Tech Tips, and seeing a video where he made an extremely high airflow PC was cool. But I never thought I'd have the ability to take advantage of making something like that for myself. Then a fan company reached out to me and offered to give me a bunch of fans, and I think I can do better. But with a budget smaller than probably one day's worth of ad revenue from his video, I am going to attempt to beat it. But in order to do so, I have to think outside the box. Firstly, I don't have the $300 fans that he used in that video. Instead, I just have 3 tower fans and a couple of extra spare boxes. I also don't have the same level of tools in order to build a solid wooden box in order to direct all the airflow into a PC. Each of the fans used in Linus's video put about 2,000 cubic feet per minute worth of air. Now, the fans that I have in total put out about 2,000 cubic feet per minute. So in order to compete with that, we'd at least need to shrink the PC in half. Now, the PC that Linus uses is a full ATX form factor PC. We could go down all the way to an M-ATX or a mini ITX motherboard form factor, but there's even a step farther. I think in order to take the record with the limited resources that we have for today's video, I think we need to go smaller. So I've had a mini PC sitting around that we can actually use, and now we can fit the entirety of the airflow through the baffles about that big on the back. Putting that much airflow through something this small should guarantee us to take the record, even if it's only at half of the total airflow. In order to make sure if this is viable, we have to actually go through and put a couple smaller fans to figure out the airflow direction inside of this. There is one fan in here, and oh boy is that going to be getting a surprise.
You know what else gets a surprise? My finger. And after crying myself to sleep, I return to finish my work. I also play a quick little game of dangle your fingers in front of the fan to see what happens.
We've got a set of 3 fans, 2 for input and 1 for output, because I really like how strong and sturdy our input baffles are. So I'm thinking if we attach the fans on the outside now with the additional help of these fans, but I think that the static pressure especially developed since it's such a small area, I think this will actually make it very, very useful. Because if we went directly from those big fans all the way down, it'd be a lot more harder to keep that structurally sturdy. So at least we have some strong points to attach to, but you can hear the sucker.
And this is with fans from Be Quiet.
And that's probably only maybe a tenth of what we're actually expecting. So all that going through this mini PC should be more than enough to get us everything that we need.
But hold on a second. We still have to figure out how much airflow we're actually putting through these fans. So a quick search online for these fans show me that we're looking at 165.5 cubic feet per minute worth of airflow coming out of each of these fans. That means in total, roughly, we're looking at right around 496.5 cubic feet per minute, including all 3 of these just regular computer fans. The 3 tower fans, at least the 2 of the smaller ones, according to the manufacturer's website, show 466 cubic feet per minute. That means in total, between the 3 fans that we have, we're looking at roughly about 3,000 cubic feet per minute worth of airflow combined.
The computer case that Linus used in his video was a Cooler Master Mastercase H5000P, which was an ATX mid-tower computer case. Has a volume of 21.4 by 9.5 by 21.3 inches, which means that we have a total volume of 4,330.29 cubic inches. And looking at the manufacturer for the mini PC on the other hand, we get 4.6 by 4.4 by 1.7 inches, which gives us a total volume of 36.4 inches cubed. That puts the mini PC at 118 times smaller than the PC that Linus used in his video.
Now when you take into account that we have about 3,000 cubic feet per minute where Linus had 4,000, it starts to make it glaring obvious on just how much more airflow we are pushing.
That means
for every cubic inch of Linus's computer, he has 1 cubic foot of airflow flowing through there every minute. That means for every 1 cubic inch of our mini PC, we have 118.75 cubic feet per minute flowing through that, which means in raw math, we have 109.69 times the amount of airflow going through volume in our PC.
Hold on though, because that's not entirely accurate. As you can see, I don't have the same abilities to make a solid wooden box as Linus and his team did. So in order for me to actually convert all of that airflow that I'm getting at from all of these different fans to a small, thin little area, I had to use cardboard, which is probably not the best non-permeable material I should be using for this kind of situation. So the airflow that we actually get from all of these fans that actually makes it to the PC is probably less. And also, we are using the raw cubic feet per minute of each of the different components, when in reality, they are affected by a lot of different things. The fans in series does not actually equate to adding the total CFM of each fan. The fans in parallel are more likely to be closer to adding the total CFM rather than the ones in series, because it's already taking the same airflow. So in reality, we are probably seeing numbers substantially less than what we have, theoretically. But when it comes down to the final results, that's what we need to test today. So let's see how much below ambient temperatures we can actually get this computer, and if it's even worth making this kind of a setup.
I just set these fans down, and I used the smaller case fans as kind of the support. Basically, the 2 smaller tower fans are going to feed into the sides, and output is going to be through the larger one. So you have 2 inputs and technically 1 output. Then next up was to start taping up everything. I had some extra cardboard boxes laying around, so that's what I ended up using. I used those, taped those up on the sides, and basically taped them to the fans. Since these shapes are really odd, I actually ended up using the cardboard, and I actually thought that was a better option because it would have been very difficult for me to go through and try to actually fix all this together if I was doing this out of wood.
Now I would let this guy go talk, but there's a slight problem. You see that guy over there? That idiot holding that microphone? Yeah, he decided he was going to crank the gain up so high that this whole video sounds like a deep fried meme that's way past its expiration date. So instead, you're stuck with Jay at 3 a.m. editing this video the night before it's posted. And now you're probably wondering, why in the world am I using a laptop to show you the results? This isn't a monitor, this is a laptop. And that would also be because at 3 a.m. it's a lot easier to plug in an adapter than it is to drag over a whole monitor.
So first up, we're going to need to go through and run a temperature test. This was actually done at the beginning of the video because putting everything on here would have been restrictive for air and actually probably heated it up more if you didn't have this fan spinning. And for our temperatures, we had a solid 55, 56 degree, which is actually expected for a small PC of this size. The cooling isn't particularly great, and also this is only a 28 watt CPU. And utilizing the customized, I would say redneck contraption that we have here, we saw temperature drops of 20 degrees down to 34/33 degrees Celsius. Now, a lot of this could be contributed to the fact that maybe the computer doesn't have the most best cooling possible, but I think more importantly, however, is that 20 degree temperatures signifies just how much airflow we actually successfully push through this computer. Now, should you go set this up? In my opinion, probably not, because the amount of noise that this sucker creates is very loud. Also, the way that we've done this is just through a mini PC, and I feel like the moment you start opening it up to a larger, full-size ATX case, similar to Linus did, we'd lose a lot of the advantages that we have here. So unless you have a mini PC that magically can overclock or a really hot cooking laptop, you probably are going to want to go through and find another alternative cooling solution. But I was more pleasantly surprised by how much airflow we got with just these couple household items, and nothing that cost $300 per fan. Anything that we use in today's video will be in the description. Thanks for watching, and make sure you subscribe. Check out the next video in which we take a whole entire gaming setup and strap it to a bike and go for a ride around town. The reactions are pretty good. And thanks again to Drio for providing us the fans that we could use in today's video. You can check out more information about them and their products down in the description.